Is it gonna pop up right here? Oh yeah, 9 seconds. Oh, this is actually what they're seeing. He's gonna have to sign a disclaimer. We're gonna have to blur his face. Steve, that's funny. Hmm? I'm just letting people roll in a little bit. It says I got 11 people in here. 13. All right. I mean, I don't really have an agenda, so we're just gonna start working. When should I start? Like 5 minutes in? Okay. That's all I got for you. Someone was. All right, well, I'm going to get started. There's really no agenda for today, so I'm just going to be talking and working. If you have any questions, I will try to kind of follow this chat to answer anything that I see pop up. So I think what I'm going to start with this morning is MMD project that I've been working on. It's pretty in depth. It's kind of a lot of manual work. It's for Italy. It's kind of like an Italian market, I guess. It's got restaurants. It's got different areas where you can just go buy food. It could be gelato. It can be you can go in and shop there. You can buy all the stuff that they're even cooking in some of the restaurants that you eat at. But they're really interested in the massive mobile data. We put some packets together for them. I got it here on the screen. Just comparing different sites, and that's what makes this project a little bit more difficult is the comparison aspect of it. Uh, it's pretty easy when you just have the one site and you go in, you pull the data for it, and then you plot it. But when you start to do these comparisons, it makes it pretty. You got to really think about a lot of stuff when you're kind of comparing the numbers together. So we're kind of going to work through this. I've done a little bit on it, so we're going to kind of be jumping in the middle. I'll go back though to the beginning because I've only really done one piece. So here's this new templates that we're actually working on. These will be rolled out at some point for everybody to use. It's kind of a snapping thing. You can grab different boxes, pull in what you want, snap it, and just enter your data points that you want to use. So it's kind of a cool template. Let you knock these MMD projects out a little bit quicker. Okay, so we're going to start with the comparison, estimated foot traffic. So this client was really adamant on having actual foot count numbers, which we don't have. We have samples. But there is a couple methodologies that some other teams do, Forum and one of the London teams, where you can actually take other sites in the market that you know what their actual foot traffic is. Usually sites like we used a couple museums, we used um, we used a couple of museums where we know what the ticket counts were. So they'll say, hey, we saw 500,000 people in the last year, and we'll actually do the massive mobile data around that center. And what we end up with is kind of our sample size compared to their actual foot traffic. So we end up with a ratio. So I kind of show you what that is here. I see what the big picture of the story here, or what the client's challenge is. I mean, what they're trying to accomplish is they just want to make sure that the area of the market that they choose, or the place that they choose, one has a foot traffic count that they think is acceptable based off what their other locations are doing. So Italy has, I think, 6 locations in the U.S. So that's actually the next part, which we're going to be working on, is the 35,000 square foot comparison. This is going to kind of be a chart that shows how their current Italy stores are versus what these other stores are in the market. And then they're also really interested in, they want to be in areas where the time of day that there's like a good sized restaurant or a dinner crowd, because they're really interested in dinner sales, or at least people in the area during dinner time. And then also they do like the lunch crowd as well. Morning is not really a big deal to them. So we want to make sure on some of the sites that they do choose that they are busy during those afternoon and evening hours. And it just really helps them see kind of what those foot traffic numbers are, what times they're busy, to see if that kind of fits their concept. So that's been the overall goal in all the markets. So just kind of show you just a quick spreadsheet here and what we'll be working on. So we found these were our 4 centers that we're actually using to kind of estimate foot traffic. So we've got the Bellevue Collection, which they say sees 23 million people a year. We got this museum that's 112,000, the Space Needle, and this other shopping center, Pacific Place. These all come from, these 2 are from ticket sales. These are just what the landlord said. So I mean, you can take those, I guess, maybe with a grain of salt, but they're somewhere in the ballpark, hopefully. Here's our sample number of pins. So we ran the MMD on all 4 of these locations. So here's our total devices by day, and then we just figure out what that ratio is. So here, one sample device, or one device per day, is equal to, say, 46 people per day. And that's, so we kind of get those estimates. We looked at kind of the average of those estimates, and then we did the math over here to see how bad it was or how good it was. In this case, I mean, we're off by 2.7 million. We're off by a million. So what we ended up doing is just using these 3. So the one that was kind of throwing it off with this was this Nordic Museum. So we just took that one out of there, and much closer here on the accuracy of kind of what they're reporting and what we would say they had for total foot traffic over a year's time. So that was kind of step 1, and then down here we pulled our 5 sites that we're interested in. We got their sample, so unique devices per day. We have our ratio from here, so we're saying 1 sample device equals 45 people. And we just multiply those across. So we're going to say Bellevue Square is going to see 10.4 million people over the next year, and then so on and so forth down the list. So that's this chart here. So they can kind of quickly see, and we've done this before, and the chart almost looks identical, just so you kind of see. This is it done with indexes here. Let me scoot this over a little bit. Actually follows the exact same trend, but instead of using an index, which the client was having a really hard time understanding, which I know a lot of you run into, we're now just using numbers. So it actually, I mean, it follows again the same flow, 2 different methods, but we're really kind of getting the same results. It's just what do we put for the total foot traffic estimate, and the only way to really figure that out is kind of work backwards. start with areas where you know the actual foot traffic, and then just do that division to get the, the sample. So the next part of this that we're going to be working on is a lot more difficult than I thought it was going to be. Um, so they want to do this comparison to their other sites. The problem is first of all, we have a bunch of different sized areas. So if I scroll through this, you kind of see we've got one location there. We've got this really long location here. Here's a huge mall. So we've got all these different sizes. And what we basically ask the client is when you do open the store, what is the typical size of an Eataly? It's somewhere between 30 and 40,000 square feet. So we're going to just say we're going to find the average pins per square foot for all those locations. We're going to multiply it by basically 35,000 to see what that number is for our comparison. The reason this got really difficult is, and I'm kind of in the process of doing this right now, is with the massive mobile data, we don't know how it stacks up on top of each other. So if there's 4 floors, we have 4 floors of data. If there's 2 floors, we have 2 floors of data. So the problem with that is when we're trying to find our square footage to divide by, we actually need to basically take the area of Pacific Place and multiply it times 4 to get the total area of what we're pulling the data for. So I've basically just been going to Google Earth and looking at the site plans for each of these real quick because I need to get the number of stories. So I know when I find the area that I can get the total area before I divide it by the sample to get the square footage or to get the counts of pins per square foot. And then once we have that, we should be able to multiply out by 35,000 and get our comparison. And the reason I want the comparison is because they're really familiar with how their current stores operate. So we're going to compare to one of their stores in Boston and I think one in Chicago. Those were the easiest ones to do. They had the least amount of other retailers sitting on top of them. The one in New York's pretty difficult because they have a bunch of office and different things above them. The LA one, same kind of concept. It was pretty crazy, but so anyways, we'll work through this, and this is what we'll start with. So we have to. The goal here is to finish out this Massa Mobile one-pager. We had this giant packet, but they don't really need everything in here. So we're gonna see if we can condense this down into maybe a 1 or 2 page document that they can just quickly look at, get the metrics that they want for each of the markets that they go to. So I'm gonna do less explaining and just more working now. So if you guys have any questions, again, I'll check back. Do they care about particular demos? The demos, they do have a list of demos that we do pull for them. Like they have a certain core population, occur certain thing. I see it says sounds like the Nordic Museum is overrepresenting. So, oh, I see, overrepresent their actual visitors. That could be the case. But again, I have no way to check that just based off what they're saying their visitor count is. So for the Nordic Museum, I think that's the one we actually ended up throwing out anyways. Another reason we threw that one out, it wasn't just because the number was kind of off. It was actually, so the 3 that we looked at, the other 3 actually sit right here in downtown Seattle. And that Nordic Museum, forget where it was. It was somewhere, I think it was somewhere out here. So it wasn't kind of in that CBD area as well. So we that was another reason we chose to throw that one out, just because it was kind of off the beaten path and not right down here in the downtown area. So. All right, so for these next steps, I got to go figure out how many stories this Macy's one is. I have 2 monitors going, so I don't know, I might be doing stuff on the other monitor as well. So if I'm talking about it and you don't see it and you want to see it, just put it in the chat. So I know these comparison templates are probably going to be more popular as we go forward because it is a nice way to use the data. Um, people want to know what site is better than other sites, and unfortunately, like the model that we have in Alteryx, it's really hard to get all that data and create any documents that are comparison style. Um, because there's so many numbers coming from, like, if you have 5 sites, you're going to see later on, like, it's pretty manual in order to get everything onto the same scale. But we're going to have to do that to when we're looking at our this chart here, right here. So time of day, when winter one's busier than others. These are all relative to each other. So we can say, Bellevue Square is, I mean, this is like 150 times busier um, than like the Ellen. So these charts, although the model will spit this data out, you can't just take the one output model for Pacific Place and just pop those numbers in because they're actually on a different scale than, say, the university. I mean, they're still using the indexes, but the averages are different. So you have to combine all this data for all 5 sites together and then do the analysis, which requires 5 different outputs and kind of combining them. So there's kind of a lot to think about when you're doing your comparisons. Um, the model is helpful to get you the base numbers, but it doesn't get you, it definitely doesn't get you the answer. So this Macy's looks crazy. I think it's like 6 stories. One, two, three, four, maybe 7. So I'm trying to figure out right now is just how many floors this Macy's is. It looks like I just found this here. So we've got 1 floor at the bottom, and then the second floor. So it's not covering that whole building. So we're just going to say the Macy's, we're just going to use 2 stories for that. Um, oh, actually, I don't know if we can do that. Because the problem is that we're grabbing pins for 7 for 7 stories. So when we get that square footage, I guess we do want the whole building, not just what Macy's occupies. So it makes it kind of difficult, especially in these downtown CBD areas. You've got a ton of stuff going on top of the site. So some of these are really hard to isolate. So you just have to make some assumptions. All right, so I'm going to move on to the next site here. What do we got? It's Ellen. I wish there was addresses in here. I don't know where that is. Let's see. Let's see if Patrick was here. He would know where this is exactly. Skip that one for now. Just go to University Village. What's up? Let's see here. If we break these out. Yeah, you're not going to know vacancies of the building. All I know is that the pins that we're collecting, and for pins, so for everybody that's used the massive mobile data, it's basically just the number of records that we got with inside that space. Um, we're not going to know what's on all the floors. It's just when we're trying to find the pins per square foot, I think in this case we need to include all those floors. Um, this is the first time we've even done this process, so I have no clue what these results are going to look like. So it could be we get to the end of this and it looks completely wrong. But we're going to kind of vet that out as we go. A lot of the stuff with the massive mobile data, at least stuff that we haven't done and done a lot, it's going to be a process kind of like this. It's like, okay, here's our idea, here's our methodology, and we'll just follow it through, and we'll look at it and see, what that looks like. It makes sense the way we're doing it, at least kind of breaking it down and doing that 35,000 square foot comparison. But we'll look at the numbers at the end. So University Village, they just have first and second floor stories. Second story looks like it may be vacant, but I'll probably just include this as the area of that polygon. We'll just multiply it by 2. And I need to find this site here. The Ellen. Actually, I'm just going to go get this polygon real quick. So if you go back into your old projects, one of the things you can do is just get the JSON file and open it up. So they kind of, I don't know why they did this, but they like blocked this to where you, oh no, can I copy it now? Copy, I don't know, I thought they got rid of this. Let's see here. Yeah, so that you can't copy those anymore. The way you can kind of hack it, if you inspect this, this is a really weird hack. Just hit inspect, bring up your dev tools. If you come down here, and I didn't figure this out, but Adriel did. You can actually type in this $value here and hit enter. It'll put all that code down here. It's kind of weird, but it works. You can copy it from there, then paste it in your notepad. So this is like your JSON file here. So you can save this. So it's just going to save this JSON file. So that's going to be the Ellen. So I usually just save it in here. And then you can just put .json here. It's kind of a cool thing. And I'll show you another cool tool. I can send some of these links out to you guys if you haven't used them. But you can take these JSON files in this website that Steve found. It's called Map Shaper. You can actually just drag your JSON file into here. So let's go ahead and do that. Where's my recents? Okay, so we can go into here and you can take your JSON file and literally just drag it in, hit import, gives you the box. You can hit export, shapefile, just makes a zip file, just drag it in your folder, unzip it, and now you have the original shape that you had if you drew it manually inside UberMedia's database there. So now I can just come over here real quick and just grab that, figure out exactly where this site is. Okay. Oh, it's right next to, what's this one? Bellevue. Okay, I know. Okay, so I know where this is here. Yeah, and to go back, we are going to update. So that Macy's one, yeah, we're going to do 7 there. I saw a comment on that. I think 7, or no, we're saying maybe add one more. Let's see. All output for those. So with the model output, it's at the model. The model, unfortunately, it doesn't spit out that GeoJSON file. Um, there you go. Steph said if you do, if you start generating a KMLs, then it's a lot easier. So you could just do that. I've just been doing it that way with the just copy the GeoJSON, save it real quick, use that map shaper website, convert it over to a shapefile, and start rolling with those. All right, so let's see here. Let's get this last one. So the LN is right there. So that one looks like it's actually all just kind of single story locations. That actually is just a lot of it's a lot of current retail sites. So this one could be just maybe they would actually build from scratch. It looks like there's not a huge building here for Italy, so it might be an area where they would just buy this property and just build that up. So that one's going to be fine how it is. Okay. All right, so now we're going to just go through and just find all the square footages of these because we're going to need that. So I do need to get, I probably will just go back to Uber Media's website and just get all those GeoJSONs real quick. Let's see, I'm going to need, I don't know if I downloaded those yet. Let's see. Let's see. Just going to get my results here from the Uber Media pool. Just want to make sure I get these right. This is a little time consuming to go back and do this, but instead of redrawing, like I know the data is for this location, so I'm just going to go grab these. So I got Chicago. I got Bellevue. Let's go get the Century City one. So I guess we did. I did use the LA one. Century City. Yeah. So I mean, I guess yeah, we could start saving these for other areas. To start a shot. Yeah. I mean, I think that would be. I think you could do that for sure. Sometimes it could get a little bit tough to do that, and the only reason I say that is because sometimes when we're pulling this Uber data, sometimes you want the whole shopping center. Sometimes people are just pulling a portion of that shopping center. So I guess we just have to make sure we have the whole shopping center that we're interested in, and then that's the file that we save. But I mean, you're right. We're already kind of drawing all these, so I mean that would definitely maybe save time in the end. It actually probably help too. Just thinking out loud with other bits of analysis that we could do more quickly if we did have shopping center if we did have shopping center boundaries, which I know we do have some from Esri, but it would be nice maybe if we could actually fill in the gaps on some of those. It may be helpful. Century City. All right, so we got Chicago. That one's fine. Let's go get that Macy's real quick. Seattle Italy update. Looks like I need to actually sit down with Steph so she can show me how to do this because it's going to take 10-15 minutes to grab all these. Okay, got Macy's. I don't care about that one. Pacific Place. Let's see. Okay, this one was from yesterday. So while I'm doing this, in the chat there, I'm a huge Spotify listener. So if anybody that listens to Spotify, if you got your, I think it's called 2018 Wrapped, I think is what it's called, where it like looks back at all your listening history for the past year, and maybe throw your number one artist in the chat there. Mine unfortunately was Kesha. Um, so I mean, you could throw some LOLs in there, but if anybody else got their Wrapped report, let's see what you got. Let's see Pacific Place, Space Needle. We don't need Ellen Good and University Village. Man, I mean, nobody. Nobody's a Spotify listener. It's a full of we got all Pandora users in here. There we go. Yeah, Marco still he plays that Justin Bieber pretty loud. Goes right through the glass doors on his office. Kids Bop, yeah. I've got quite a few Frozen songs on the top of that soundtrack. Kids love that. All right, I think we got all those. So what you can do too on this other site to make this kind of go faster is you can actually put all these. I think I already actually had that one. Put all these out here. Just do it all at once. Actually, I don't need Nordic. Got that one. Good. Okay. So you can actually drag all these in at one time to that other site, which is kind of nice. So if we go to this map shaper, just create all these shape files at one time. You can export these all. You can just select all of them, export them all out as shape files as well. There you go. So that's kind of nice. We'll just throw these into the folders that they go into. Pacific Place and then University Village, and then we'll be on our way in Arc Pro. Actually, you know what? I'm gonna take these as well. Okay. So now we just need to project these and get the square footage for each of our sites. I'm actually going to export this and put these all in the same folder. We're going to make a quick model to do this. I don't know how much of you guys use the model builder, but it saves a lot of time. And for something like this, and I'll show you guys, it's just really, really easy to do. Um, put that one in there, and I'm just going to put this one in there too, real quick. So it should be all the sites that we need. Okay, so to do a model, I mean, what we want to do here, we just don't want to do it 5 times um, or 7 times or however many of these we have. Just go to new model real quick. This is the way I think about all this stuff is like if I don't have to do something 7 times, I'd rather just come in here. It may take, I don't know, 10 minutes to set this up. I maybe could have been done, but at the same time, there's not going to be any error once it's done either. So I'm going to iterate through a folder basically just means go select the geodatabase, go select a file. I'm going to select this one called shape because inside there I have, these are all the properties here, the shape files that we just got. I want to project these just to make sure I'm in a good projection. So literally just type project. You can think of these as like a pretty linear process. I'm just going to input that in there. You can open up the tool, just like, I mean, this is the same tool that would sit over here. And so we want to select an output for this one. So I'm just going to use one of my favorite, like one of my favorited ones. I use, a lot of times I use this Albert's equal area, or this U.S. National Atlas equal area. In this case, if you do get this, so this is a datum transformation, I'm just going to switch over to this one because it's not going to cause that. Oh, no, it is still. Should be okay, but I'm going to go back to this other one just because I like that one better for area. The tool still works, it's just giving us that warning. So we're going to project it. Problem is we have to save that before we do this. So what I'm going to do, let's just create a new geodatabase real quick in here, just so we have our output, our area for output. So I'm just going to call this scratch. So each time one of these comes in here, it's going to say, okay, we need to output it and save it. So we're just going to go to that scratch database. What you can do here is, because the name of the file is going to change constantly, if you put this number sign with name there, it actually just takes the name that's in there and it'll save it as that file. So we're going to go ahead and do that. So it'll fill this up with these same exact names, underscore PROJ. And then the last thing we need to do is we need to add our geometries to it. So we have our square footages. So we're just going to add geometry. And then we'll just fill this out like you normally would. So we want, I do geodesic area. That just means it accounts for the curvature of the Earth. You could just use normal area as well. They're not too much different. Oops. So put that in there. Here we want feet. I want to do square feet. And we're just going to select that same coordinate system that we selected earlier. Hit OK. So this is literally our model right here. This will give us all the stuff that we need to continue forward. I mean, you could even take this one step further, you could export this to Excel. You could do CSV, whatever you want to do. But I mean, that's it. So we're just going to let this do its thing. So I mean, that took maybe 5 minutes, and it's going to do all 7 of those shape files for us. So this one I'm working off the network, so it's actually going to be probably a little bit slower. Unfortunately, my hard drive is filled because I have one project that's 178 gig. And so I'm hopefully fixing that in the next week or so. So I got a new one I ordered. Also, just a friendly reminder, don't let friends lose their emails. For everybody watching, we definitely don't want you to be part of that, where you sign back in. So there you go, flyer. Zoom in a little bit for you, right there. Hey, if you guys haven't hit the subscribe button as well, go ahead and hit that down below. We'll be making emotes coming out later. So for how long you subscribe, month, 2 months, you get access to some different JPEGs. I think you may have to be signed in to subscribe. So sign in if you haven't. Smash that like button too, somewhere down here. Yeah, I think we might need to make some room for this. Let's see, how much space do I have here? Got 55 left. I think we'll move this off the network when we're working on this today because it's going to be a lot faster. Usually this would just kind of, I mean, this would go right through all these pretty much instantly. It's probably worse for a lot of you guys too out in the field. And this is delaying us from getting into the fun stuff, so let's let this finish up. Let's see, can you save the models and reload them? Yeah, so the models, yeah, once you make these models, it just becomes a folder actually. Let me show you. So if we go to, so inside here in your actual folder that you made for your project, you can, this is that toolbox right here. So if you have a bunch of models in a toolbox from other projects, all you have to do is right click on your toolbox. So right there, add to project. So where it says add toolbox, you would actually just click that button. I think it's not there because it's running right now. You could just navigate to your toolbox in another project. Just click on it; it'll add it in. So you'll have two toolboxes over here. So if that's something that you want to do, and I think you can actually favorite these as well. I don't see that. Okay, that's unfortunate. Some of these other folders options, you can favorite these, and right there where it says add to new project, like if you're using the same folder all the time, like anytime I open a new project, data and distributed data are automatically mapped when I open up my Pro. The way you do that is you add a folder, and then once you add the folder, you check add to favorites and also check add to new projects. So every time you start a new project, you don't have to re-add these folders. Doesn't look like you can do that for the toolboxes. That would have been cool if you could. So you just have to kind of navigate to it. So you would do add, and then you would just go navigate to it. Or you could even, not even using that, you could just copy this toolbox and just go paste it in your other project folder. And then it would just be in that project moving forward. So models like this, I usually don't save. I mean, you can save them. Um, I mean, it's just some of these are just as easy to remake. Okay, so there's all our stuff. I'm gonna save this real quick, and I'm gonna copy this folder off the internet or off the drive here because I think it's just gonna be much faster if we put this on the desktop for now. Let's see. So let's take that projects. All right, I'm just gonna put this in here. We'll just reopen it. Actually, maybe the file's open. Okay, so let's see. I might have to close this one out too. Nope. All right. What else we got here? What else we got? Save this. What's up, buddy? Where's our desktop at? This is the normal stuff that I'm sure everybody runs into every single day. Can't copy, stuff open, all these fun things that. Oh, come on. I don't even know what else I got open down here. Oh, you know what? I wonder if it's in here. I don't think that would matter, though. was Macy's. Okay. Hmm. Oh, maybe in here. Oh yeah, this is where it's at. Okay. I think this is in that folder. Put this on my desktop real quick. Oh, come on. Somebody close this out. Oh my gosh, stop. Is it just that folder? Close this folder. Could have been that actually too. Hopefully we didn't just delete all that. Let's see, what's the MOS number? 359 204. Oh, so it copied everything but this one. Oh, it's right there. Okay. So let's see. Can we put this over here now? There we go. I guess that's gonna stay over there for now. Okay. Let's get back into this real quick. All right, so we just want to go grab the square footages. So we have those. So let's see. Let's grab those from each of our our files that we just made. Okay, so University Village. Let's see, square footage. We're gonna do. Let's see what our square footage was there. So 190,000. Ellen. 41,802. Just writing them, just jotting these all down over here in that spreadsheet. Pacific Place 107,923. Macy's 80772. Let's see, Bellevue. This one's gonna be massive. Okay. We got our Century City. So those are going to be Central State and Chicago will be our comparison ones. So Chicago is 15343. So these ones are a lot smaller because these are just portions. These are the actual Italy locations within the mall, um, not the whole center itself. So these square footages are going to be a little bit smaller. Let's see. 42. Okay, So I just show you guys what I did here. I just put those right there. So that's our square footage. Got our numbers here. I do need to go check these for number of floors as well before we do the rest of the math here. One thing we do need to do though is we do need to get the number of unique devices per day. I know a lot of you just use the full model. Alteryx is your friend, so I would definitely jump in here and try to use it when you can. But like this simple thing right here will give you the unique devices per day. So instead of running the whole entire model when I don't really need the whole entire model output, oh, this is going to be, okay, I should have left this on the network too. And I'm sure a lot of you have done this a million times. I don't know why it won't let me close this. So we actually need to put this back on the network because I need access to my pins. So I'm sure this happened to you guys quite a bit too. It is nice working off the network because it's way quicker, but then you run into, I mean, this problem here, just kind of going back and forth. Thank goodness this file's this file's pretty small. So, all right, so we're gonna hop into here, jump back into that file, and so we want Century City. I need to get the number of unique devices per day for this. So I'm gonna go to all files. I'm just gonna select my pin report like you normally would. You're gonna hit that. You're gonna hit tab. So this little sweet snowflake right here, this is what it groups by. So think of this as a pivot table. I'm literally just saying I want my device ID and the date. So anywhere those are the same, just group them together, and that's it. Like hit play here. It just did that. So this top one is the uniques. So that's the one we're interested in. So here's the number of unique devices per day for the whole year. So in that space, we have 37,588. So I'm going to put that number just right here in our sample for the Century City location. So let's see, 37588. And then I need to do the same thing for that other site, the Chicago site. So I'm going to jump in here, just grab that pin report. You can run these things all through the model if you want, but then you got to make like the grid and the heat, all the different stuff, the tessellation and all that kind of stuff. So we did the exact same thing. So here's all those duplicate records. So in that site, we've got 36948. So easy enough. Then I'm just going to go check these two locations real quick, just for the stories, so we can multiply our square footage out. So we got Chicago. Let's see. This is. I'm gonna go find this one. Most of these ones are hopefully in. I think these ones were in centers. These other Chicago ones. Or this one may be actually the standalone one. Oh no, Shops at Northbridge is what it's in. So let's take a look at that real quick. Oh yeah, this one's a little bit weird. So this one might have to just go look manually. I think it may just be a ground floor one, but the center itself is almost here. These are all the levels are here, so you can see that the Italy. I don't know if anybody knows what this means. NBD. I don't know. If you know what it is, throw it up in the chat there. But level 1 is only for this site. Like these are where the sites are here. So not sure what that one is. So let's go take a look though on the street map. Okay, so that's here. I like that. No big deal. Yeah, so this one we've got a couple going on. The good thing about the Italy is they probably actually fill this whole building. Their spaces are really, really massive. Or at least, I mean, they probably fill one, two, three. It's probably like 3 or 4 stories. Go take a look at the actual Chicago Italy. So you guys you can get an idea of what these things look like actually if you haven't seen one before. I mean, they've got full like escalators, multiple stories, really open kind of concept that you can go kind of shop in here. It's kind of cool. Yeah, it's pretty cool places. Okay, so we did that. Now we got to go to that Century City location. Westfield Century City. What's up, bud? Say, hold on, did I get rid of it? Oh, Italy. Here. Where is it? I'm on it right now. Sorry, we're looking to see if they misspelled lunch. Hmm? Oh, click the arrow, I'd say. I think that's how they spell it overseas. Hmm. Okay. Let's see. Actually, no, I need to go back to that Westfield Mall. Westfield Mall. Okay. Oh, wow. Okay. So this place is massive. That's parking probably. Oh, this was this one. Okay, yeah, this one's like three. It's like pretty much three stories here. And this one's a little bit different. We don't actually care about the whole center here because I didn't pull the whole center. It's just really where the Italy location is. So we've got the first floor, which is there. I don't know what that is. Two, three, and then the rest is just like this parking garage here. Three, four. Let's see, we got our Italy. So we got one, two, three. Looks like this one, there's nothing there, but there is parking here where we could be capturing pins though. So we'd probably do four on that one. And we'll see what these, well, we'll see what all this looks like here when we get done. Okay, so this is what we end up with is this chart here. So we have all our samples, what our estimated counts are. Um, I'm not going to estimate the counts for their current locations. The reason that is if you are going to do these estimations and actually try to get foot counts, you want to make sure that the sites that you're grabbing the data for to do the comparison are within the same market. So all these ones here are within Seattle. So I felt pretty comfortable using our baselines that we got from the Seattle market to project into the Seattle locations. The Uber media, I mean, it is different in different geographies. So kind of maybe keep that in mind too. It's one of the things I think about is when you're doing some of the comparisons. If you're comparing a site in Montana to a site in LA, just inherently there's going to be way more data in LA. And people just and actually talking to Uber Media, different people use different apps more. Like in the Midwest, they see a lot of like weather apps being used, where in like urban markets and stuff they don't. So there's kind of some discrepancies by region. So if you are going to do kind of estimated counts at any time, make sure that you pull the sites that you pull. Um, the sites that you pull are within the region that you're kind of estimating the counts for. then we're going to do pins per square foot. Okay, so this is be what the numbers look like. And we'll see if we'll make a chart out of this. So what we're basically saying is, here's our total square foot that we were capturing pins for, which is this number here. So this is a massive mall area that we did here. But so we've got our total there, and then we do the division on those. So number of pins per square total square footage. So 0.15 people per, or 0.15 pins per square mile. And then we're saying, okay, how many pins would we get in a 35,000 square foot area, which is what this is. And so this is kind of our comparison. So that Chicago site is actually insane, though. It's kind of way out of the normal. Hey, Donahoe, you following this? Is that what we talked about? All right, so look. Um, so I got my total square footage for the polygons. These are like the number of stories, though, that we're collecting pins for. You know what? This could have actually. Hold on. Let me go to one thing, though. On that one Italy site in Chicago, we could add another floor. Let me go back to it real quick. Just want to make sure because that might be. That's this one. Here, I'll show you. Yeah, I'll show you. Hold on, where's that Italy in Chicago? That's not it. Chicago. Oops. Chicago. Right here. Oh my gosh. Just the internet, man. All right, there we go. Okay. Was that it? I think it's right. I think I put 3. What? Hmm. Yeah. I make everybody wear gray on my team on Thursdays. Okay, so hold on. So I got my total square footage of the polygons. So of the actual. So like each one of these square footage is right here. Number of floors is right here. Yeah. So total square footage. Then I take that and I divide the number of pins by the total square footage. So I'm getting. So this is. Yep. No, no, no. Oh yeah, that's unique pins per day. Yeah, unique pins per day. So I'm seeing 0.15 per square foot, which is fine. Then I'm multiplying this number by 35,000. Well, 5,000 sample pins. You could technically multiply this now by the ratio, and it'd be this. Here. Oh, I gotta put my ratio down. So what this is basically saying is, out of what we see per square foot, Bellevue Square, you would see 234 and a 35. See, the thing that's crazy is like that count is so much larger, but the center is huge. So that's what we kind of want to show. So that's like our density metric. So I think what we would end up with then is this would be like estimated. Look how high that Chicago one is. I need to figure out if that's 3 or 4. I need a consensus from the team. How many floors do we have here? I need to go look this up. What building is this? 53. Actually, let me go back to the website. 43 East Ohio Street. Why would that be on Zillow? That must be a different. Well, the Italy's only 2 stories. Um, yeah, I mean the Phoenix dress code. Sorry guys, I actually kind of broke the dress code today just because it's the end of the year. Yeah, most of us. I'm usually in a button-up long sleeve shirt. I promise. And make sure you guys edit that out of your out of this live stream. I'm just searching right now, guys, just to see if I can find that actual how many stories that thing actually is. Might have to call Doug. Man, there's nothing on this site. Let's see. I'm actually gonna email one of the ladies that's working on this account and ask her real quick. In this case, it's kind of important that we get this right because it's part of our estimate there. So So while I'm waiting to hear back from that, I'm actually gonna just jump to another project real quick. And sorry, I do this a lot during the day, so that was the only thing that was maybe gonna be difficult about this is trying to stay on the same topic. But like I said, I want to just make sure I get the stories right. So I'm gonna wait to hear back from her. Um, I do need to. I'm gonna make a quick heat map here. This might be interesting to some, or you guys might. I know it takes up 2 floors, but I actually need to know the total floors of the building. Just because even though the Italy takes up 2 floors, I'm still grabbing pins from the floors above it. Um, so it can be that's why I still need to kind of include what's on top. Um, yeah, man, I actually need to make some mods. Keep this chat in line. Too bad we don't have like or do we have? Oh, there is emojis. All right, cool. So, um, why don't you put a smiley face emoji in the chat if you're a Twitch stream watcher? We'll see all the video game nerds in here. Here, I gotta put one in for myself though. There we go. Oh, even Jen's getting in on the fun. Now, are you guys watching like IRL streams? Are you watching gaming streams? Well, what do we got? Yeah, I would rather play too, but something about watching people that are really, really good. All right, so this one here for anybody that makes a lot of heat maps, if you have like a recurring client that you constantly make heat maps for, maybe tune in for this next little piece here. So I've spent some time kind of creating a heat map model. It takes a little bit of time to set up for each client, and when I say a little bit of time, I mean maybe like an hour, hour and a half. But the advantage is you can make a heat map in 30 seconds. I'll kind of show you that right now because I do need to make one for TD Ameritrade, one of the clients we make a lot of these for. So it looks like this one, they want to do it in Frisco, Texas. So I'm actually going to just give this to Nadine's group. Um, so just get ready for that moss to come over, Nadine, if you're on here. Okay, so let's see, it's in the North Dallas area. So the only thing you really need to get going is your hex file or your grid file. One of the things that we added, and I didn't give this to Sarah last week, which I should have done. But in the databases that you guys have access to, so in the folders and distributed data, if you haven't checked this out or haven't come across it yet, in the base layers here, geodatabases, you'll see this one in here that's called CBSA quarter mile hex. There's like 180 hexagon files in here that are already made at a quarter mile, um, which is really nice. So you don't even have to make them. I mean, these are all the major ones, so you should have most of the markets in here. But in this case, like I can just go to Dallas right here, and I can just add it to the current map, and just zoom to the layer here. So it's already got your quarter mile hex in here. Let's see. I'm not sure I want to use this whole market area though. Let's see. Please create a heat map. So they kind of want to focus on Frisco, which looks like it's up here in North Dallas. I have a hex that's just for Dallas. It doesn't include Fort Worth. I might go ahead and use that one. I mean, this is literally the hardest part of this heat map process. this point, the way I have it set up. I do have one, I think, for in another project, so I'm gonna go grab it real quick. Try to reuse as much as I can, but oh, okay, 4 stories. All right. Oh, look at that little video game one. Was that in the standard emotes? Yeah, you can. If you hit the subscribe button below, you get access to that video game controller emote. Oh, I don't, Steve, I don't see it in here. Did you upload it manually or what? Oh, yeah. Here's the when Jaegers plays video games, he's still using this. Yeah, he hasn't worked his way up to the better. He doesn't know there's controllers now. Okay, so I'm just gonna grab this hex real quick, and then we'll hop into that heat map, and I can show you how that works. Maybe I'll just go through the model real quick, and it might actually be helpful for some of you guys. So in here, I do have one that's just Dallas. I think this is just Dallas. Yeah. Okay. So I just kind of cut that off there. So I'm gonna save this hex out. Actually, let's see if I have a clean version of it. I think I may, but I don't know where it is. So let's save this one. I'm just gonna throw this in that other folder. All right, where should I put this? Oh, it's here. This is where I want it here. Oops. Okay, so I just want Dallas quarter mile hex. So let's put that in there. All right, so get out of there. Just hop back into this other project, which is here. Get rid of that. Go grab my quarter mile hex. So we'll try to make those too for the rest of the U.S., the rest of the metros. But like I said, right now they're not like that. All right, so we've got our Dallas one here. I'm just gonna bring that in, and we got to delete a bunch of this other stuff out of here real quick because there's a lot of different things already in here. So easiest way to do that, if you haven't been in here, just table view fields, and then you can just select a bunch of stuff at once. So we can just literally come down, select, and hit delete, and hit save. Let's see. Um, you wouldn't run into problems with IDW. I mean, all it's still doing the exact same thing. It'd just be interpolating the data between the 2 points. But I mean, most of the time, I don't haven't really been doing IDW at all lately. It's an extra step. It's I mean, it doesn't show too much more. It's really more just it looks nicer. So I mean, that'd be up to you guys. But most of the time, I just actually load up the this hex file as is. Yeah. Oh, over there? Yeah, I mean that's how any IDW is though, even if it was a grid. It would So there's two. So what he's basically saying is on the edge here, sometimes when you have the IDW, it's gonna like interpolate from this point to this point over here. So you have this like you everybody's seen it. It kind of looks like this crazy weird like stretching of the colors. There's a couple ways you can get rid of that. One is when you do your IDW, you can clip it to a feature. What that'll do is it'll literally clip it to this, so you won't have any problems with that. Or the other option is a lot of times these areas on the outskirts, you could just set the values of those. Like most of these are not going to be scored well. There may be exceptions to this, but most of the time, anything on the outskirts isn't going to be scored well. And so you can just set those to like no color. And so most of the time, your heat will still be in here, and it'll get rid of all that other random stuff on the outside. You just have to test that though with the market. Okay, so our file's ready to go here. That's all you need. You just need a grid, a hex. That's it. So I have a model here. I can kind of run through it quickly just so you guys can see what it does. But this will make a heat map for you. Like I said, it takes some time to set it up, but again, I don't have to get the data. I don't have to do any calculations. It's just going to do it for me. So the way you do this is, again, there's an iterator here. So the reason I have that is I could technically put all 180 hex grids in here, and I could run every single heat map at one time, which I've already done for this project. And then they switched up the data. So right now I'm doing it one off just because I haven't had time to rerun it all the way through. So um, again, you're just going to navigate to your file. So in this case, I have this Dallas one here that I want to do. Now you can see I have a bunch of other files in here, and I actually don't really want to iterate through these right now because I don't want to rerun those through. So what you can do with this iterating thing is you'll see this wildcard. Just put the name of the one that you want to run in there, and it's only going to run this file. You can do some cool stuff in here though, like if you want everything to run through that has anything before it underscore hex, it'll just find the ones that say underscore hex. So it'd run this one through, it'd run this one through, it'd run this one through. Um, so you can do that if you only want to single a couple out. If you have points and polygons, but you only want to run the polygons through, you can actually select between different types here. So like lines, points, polygons, which is kind of neat as well. Um, so just kind of a cool thing in the iterator. But in this case, I only want to run the Dallas one through, so I'm just going to hit OK on the Dallas one. So just kind of show you what this is doing. I'll just kind of do a quick step-by-step. It's going to grab the Dallas one. It's going to turn it into points. So it's going to take the hex. It's going to turn it into points. It's going to make a 1 mile buffer around all the points. So just say your project is a 3 mile buffer. You literally just click here. Well, you click here since it's a parameter. You put a 3 in right there. Goes through. You pick your data variables. So in this case, I've got a couple variables in there. So this is like whatever variables you have for the thing. You add some fields, so I'm adding a field called people because I'm combining daytime pop and residential pop. Calculates that, so you can see it's population plus daytime pop right there in that box. And then then it creates this next section here, which is called summary statistics. So you run summary statistics. So this is just like if you exported this into your spreadsheet, and you have to calculate your average, you have to calculate your standard deviation, then you've got to do the z-scores and all that kind of stuff. This grabs your averages and your standard deviations. Add a couple more fields. So these are all the fields. Like you have to add variable 1, the weightings. This is just like the spreadsheet essentially that you guys follow. So here's your weightings. Here's your z-score. Here's your capped z-scores. Here's your composite score. Get your first index, and then you get your adjusted index. So you kind of it just adds all those fields for you. Then it goes through and it does the capping. In this case, we usually cap at 3. I'm capping this at 5. That's just the way that these two variables interact together. This is by doing this one a bunch of times. This one I do want it to be a little bit higher. I don't want to cap these all at 3 for this population, because then the other variable takes kind of, it gets too powerful. So it does that, and then it does the adjusted stuff and adds some fields, and then it joins it back to my original hex down here. If you want to run a bunch of these at once, you can, this append up here can just keep adding those to the bottom, and you can just make one giant hex file for like all your markets. But that's, I mean, so in this case, this is done, so I just hit validate. I'm just going to hit run on this. It's going to make the heat map for us right now. So right now it's pulling the data for all those buffers right now. So now it's kind of calculating my fields. It's finding all those averages and standard deviations. Just pop through all those. Now it's going through and putting all the weights in and all the different things. And then it's going to start moving down this line, which is going to be the capping of the variables. And now it's doing all the, it's basically recalculating that average and the max value. So you guys, so it like takes that index and just converts it. So 100 is again average. And then it's going to join it back to the original file, which it's doing right now. So yeah, that's it. So if I go back to my map now, I can just hit refresh over here. So here's my Dallas quarter mile hex. I'm just going to add that in. If I go to symbology, I can do my graduated colors, and I can select my index adjusted, and boom, there's my heat map right there. So now I can, do all my styling, change my, number of categories. I forget exactly what these are. I think I forget how many I was doing down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 categories, and yeah, so that's that. And then now I'll just have to zoom in, and actually these ones end up being just paper maps. So I do have to sit there and put all the shields on and make sure everything looks good. So my max is 201. And I won't go through all that with you guys. I'll come back to this. We'll jump back to that other project, but I just wanted to kind of get this rolling. So this one, be careful here too. If you ever have too many values or too many, it only like samples like 10,000 grids. So you can see right there, it just defaulted the max to like 120, but the max is actually 201. So be careful on that. You'll see that like some of your stuff is just left undone. So I'll switch these over, and then I'll usually just change this bottom class to no values here. Apply. So, and then I'll just adjust all the coloring. So you can see this one's pretty crazy. So this is the coloring on this one, or the 2 variables that we're using, is a combination of daytime pop and workers. So the CBDs are going to show up here, where sometimes in some of the markets, I'm not too familiar with Dallas. I don't know if a lot of people live down there. But if they didn't, you would still get heat in areas where there's no residential population, but there is a daytime pop. So it's kind of a combination of both of those, and then it's also kind of an investable assets number. So how much investable assets they have in stocks, bonds, and mutual funds. So I'm assuming if we narrowed this down here, lower these ranges here, so we don't have the whole entire thing black. Get a much better looking heat map. So one of the things too is if you guys do a bunch of heat maps and you load them up online, um, depending on how many markets you do, just say you have like 20 markets and you're building a web app, what you don't want is 20 different buttons to turn your heat layers on. And a lot of us, that's how I started out. I would literally have a layer for every single heat map. What you can do is you can make just one big hex file, so it has all your markets in one file. The advantage of that is it's just one button in the layer list. So it's just I want to see my heat maps. You click that on, it's every single heat map across all the markets is turned on at one time. The way you can do that, though, one of the things, if you do want to do that, is when you append all these together. I'll just show you this real quick because it was in the table already. Right here, I have a column called Color Cat, which is like my color category. Because you guys have probably noticed too, when you guys do make heat maps, not all the ranges are the same for every market. You might have some markets that look good with like a cutoff of 125, 150, 170, whatever, and so they may be all different. So what you can do, and Steve actually put this together. Let me just show you real quick. Oh, it deleted it out. Oh, I can't show you. I'll have to get it from Steve again. But what you can do is there's a little you can do a little calculate field on this. You can drop this to arcade expressions, and what you can do in here is you just put your ranges in there. So like 107, 117, 120, 138, and you hit go, and it'll just number these. Like, so if it's less than 100, it's going to give it a 9. If it's less than 110 but greater than 100, it'll give it a 1. And then that way, when you go to make your thematic to load it up online. Oh, you just sent it to me. All right, here it is, guys. I'll show it to you. So you can kind of see an easy way to do this. Oh, you know what's probably in here? This is an old version. Sweet. Okay, so here it is right here. So you just take this quick statement here. This one's for another one, so it says final index. It doesn't say color cat, so I won't be able to run it. But you just put your numbers in right here. So you just put like 176, 164, 150, all the way down, and then you'd run this, and it would just populate those with the numbers, and then you just run your thematic off these numbers. And so every market looks good, and it's even though the scales are a little bit different, you always stop it at 100, so all the markets are still showing above average areas. And then that way, when you load it up online, you just run your thematic off this color column instead of the actual numbers, and you can do it all at once and load it all up online as one feature. So it's a nice thing for the client. They're not like diving around looking for a bunch of stuff. I'll show you a quick example what that looks like, so you guys can see. This is kind of like off topic, more like training, but it's really helpful. So in this one here, if you come to this side panel, now this one has two because they left the old one in there, but because they revised some stuff. So this says market analysis revised. So if you open this up, it's only one. Like if we looked at the, actually I gotta zoom in to do it, but it's only one layer in here, market optimization, or market analysis revised. But this is like 37 market heat maps. So like when you zoom in here, so here's Phoenix, and then over here you just have above average, and then averages are 100, and it just kind of scales up from there. But it's just nice. They have one layer, one call out box. Another thing nice for you guys, it's one call out box. So when you link your feature service and you create these call out boxes, you don't have to create the call out boxes 37 times. You can just create the call out box one time for every single market at once. Um, so just keep that in mind if you do have ones where you have a bunch and you don't want to fill. This layer list was already crazy. So to add 37 other markets in here to turn on and off and do 37 different call out boxes, it can be crazy. So just a heads up there on the heat map stuff. Um, so I'm gonna take David's word for it. So he's saying it's 4. Going in the chat here for the Chicago site, which at least based off the numbers, I mean we already that's another thing. Kind of like, I mean, a lot of this stuff you look at your data and you're like, okay, that's like way high. I mean, it still is high compared to the other ones, but with the 3 in there, I mean, it's really high. So it's like, okay, that's like just a cause for concern. So we really want to double check. And it ends up being the Chicago one. David was saying it was 4. So we'll just run with that portion. Yes, so 4 stories. So that's perfect. Is it? Well, he says it's 4 stories at the version Italy's in. Is the building itself though more stories? David, I don't know if he knows or if he's still here. We still got 27 people here, but they could be in and out. Actually, let's see here. I got an email as well. Got an email too to make a quick login for one of these for a project. Actually, this Adidas project right here, so I'm gonna get that going while we're waiting. This is perfect because Inigo's just on here, so he can just make it right now. Oh, I should have wrote add. Hey, Inigo, can you add Steve to that too? I talked to her yesterday. She just wants a login for the client. So I think she said she was having trouble logging in, but I think it had to do with some of the like Esri issues that were going on yesterday or the last couple days for logging in. David, a portion is a high rise, then it drops down. I know. I think I pulled it around the whole thing. Man, these high rises. So for like Jen in DC and Steph in New York, this is when we all feel your pain. Nothing's flat like out in suburbia. These ones in the cities get a little bit tougher. Okay, so I'm gonna go with this for now, which I think it seems pretty accurate. And again, I'll work with the broker on this team too, just kind of vet out what we did here. So in this case, we're just going to insert another table because we got to get this over in the other. I probably sort this as well, just since the other one is sorted. Oh, whoops, got to do that. Okay, so we'll take this and this. Whoops. Like I said, hopefully too, I don't know when the exact rollout is of these, but hopefully we can get these one pagers. I think are going to save a lot of time. Oh, let's see. She says she doesn't know. So that's a 60,000 square foot easily, but 2 floors, but I need to know what's above it. Okay. So I think we're going to just go with 4 for now. The Washington Monument. Yeah, you guys, yeah, you're dealing with some crazy stuff. I'm just trying to get this chart, and we can just kind of skip this, but I wanted to show you one feature here that you can just, and people might already know this, but you can just how you can copy paste um, these charts right over to Illustrator, which is kind of nice. I was trying to find out where that. There's a way to make. Oh, maybe I got to click on these. There we go. So negative 12 and 70, 72. I just want these to be the same size. Okay. So you can just copy these charts. Oh, I close that out. Boom. It's on my desktop. Put that back up. So when you're inside here, I mean, you can just take these charts and paste them in here, which is pretty awesome. They have like a ton of like weird clipping masks and stuff on them. So just like right click on them, just release all these clipping masks. Start deleting some of this stuff off. I'm probably going to delete all this stuff off and just redo it in some other text here. Um, Again, there's just a bunch of clipping masks, but as long as you keep doing that, you can just quickly get your chart like ready to go. So in that case there, like this is already ready to go. I'll drop it in here. We'll do our comparison estimates and we're good to roll. So that's another part of it. So now we're going to move to some more harder stuff that we have to calculate for this. I don't know the easiest way to do it, so we're going to kind of learn as we go. Because I'm trying not to, and I might need to at some point. I might need to run these through the model, but I don't really want to because that means I have to run 7 of these through the full model, which is going to take quite a bit of time. So I'm just going to see if I could get to what I need without having to do that. So the next chart we need to make is we're going to get rid of all this stuff because we don't need it. And we're going to make one large chart here. And I think what we need to recreate is going to be the day by hour, like how busy it is, so they can kind of see, is it more of an afternoon location compared to other locations? Is it more of a dinner location? But instead of the one that the model spits out, we have to do this compared to all sites. So let me show you what I mean by that real quick. So let me go to the projects. I know I just ran one of these. Let's go into here, just so you guys can see what that looks like. So you get your model output, which is I think it's this one here. So okay, so you get this model output, and what we're trying to recreate is day. Where's that day by hour? Okay, so this is what we need. We need this table for all the sites. Because I want how many people per hour that we're seeing per day. So, midnight to 1 a.m., 1 a.m. to 2 a.m., 2 a.m. to 3 a.m., and then the number of people. So if I took this, though, and graphed it, and then I took the other site and graphed it, or sorry, if I took, it's just the index here. Oh, these aren't numbers. Let me convert these to numbers. Okay, so the average of this is 100. So this is the index. If we took this index and plotted it, and then we took another results table and plotted it, they would technically be on different scales, just because we're taking the average of this count and we're dividing each of these by that average, but that average is not the same average as, say, another site. So what we need to do is find the average by hour for every single site, every day by hour, and then use that as our average. So that can be kind of tricky, and that's why these comparison ones take a long time to complete, because the model's not going to give you that. I mean, it is going to give you this column, but it's not going to give you the indexes ready to go. Just plop them in and run. Um, so instead of running the whole model though and getting all of this, I was going to see if I could just get this page for each of them. So that's what I was going to try real quick. I know I can do it with the pin files manually, but some of these pin files I don't think I will be able to open is the problem because they're going to be too large for Excel. I can show you how to do it in Excel because I know a couple of these would be fine. So I'm going to start with that actually. So Bellevue collection is going to be way too big. But just say we'll start with let's start with this University Village one and get our numbers here. Actually, you know what? It might just be easier to do in Ultrix. I don't know. I'm torn. Probably just maybe just try to do it in here. So we're gonna make a quick Ultrix tool, or hopefully quick. We'll see how quick this goes. And if it starts to get too time consuming, I mean I might just run these through the model, but I think that may still just take way longer. So let's see if we can get this to work here. Okay, so we're gonna go back into this folder here. So we'll just start with the Bellevue one. Actually, no, let's not start with that one. That one's gonna have the most data. So start with a smaller one that's easier to test. Actually, probably this one, the Ellen. Okay, so we're gonna grab the pin file. Pin, right there. Okay, so for this one, we need to split out. So we want the hash ID by date, but we also want it by time. Um, and the reason we want that is we want to know the bucket of time that it's in, but we also, if the person was there between 10 and 11 a.m. and they were also there between 11 and 12 a.m., that's fine. Like we still want to count them. And so we're going to just try to hopefully do this quickly. There's a parse by date and time because we're going to need that data. So let's see if we can do this here. So what's our time look like? So we want to basically, we just want the hour out of this time of day. I think we can get this. Maybe. Is there time in here? Yeah, here we go. Hours, minutes, seconds. Let's just see what this looks like. So one cool thing about Ultrix is you can just kind of keep running it and see what your output looks like. So if this splits it how we want it, then we can move forward. Yeah, even though this is a small file, these smalls, I mean, it's small relative to what a normal pin file could look like. So okay, so let's take a look at this. Yeah, they didn't do anything. Date time out. Okay, so let's go back into here. Oh, well, that would be helpful if I would have selected the actual column that we needed to use. 4 minutes, seconds. Let me make sure that stayed. Time of day. No, I think I want 09. I wonder if I could just use this instead. Actually, what kind of field is that? Maybe that's what we should check. I don't think that's what I want, actually. So let's see. This is time. Where's that hour? Split this out using the delimiter there. Might actually work. Number of columns. Leave extra in last field. Output time of day. Let's try that. All I'm trying to do here is I'm just trying to split those hours out. I didn't like that either because I switched it to time. Let me switch this back to string. Try that. There we go. Okay. So I think we're good now. So time of day 1 is our hour. So that's going to be how we know what bucket to put it in. Um, so I'm going to let's see, I'm going to get rid of that. And we're going to, so this little select tool is kind of nice in Ultrix. You can just, if you don't want other stuff, you just get rid of it. So like I don't really care about having that anymore just because I only want the hour. And then you can actually rename stuff here. So if you put hour right there, uh, and then you can browse this. So now when you get your final data set here, now we just have our hour here. So we want unique devices by day per hour. So to get that, we need to use that sweet snowflake, which is this. So what this is going to do is we want unique device by day. Or do we, ooh, we want day of week actually. Let's go take a look at this table here. Where's our day of week at? Where's my day of week went? Okay, so we actually want it by day of week. Day of week by hour, unique device. Okay. So hash ID, day of week by hour. So what that's going to give us is all the unique versions of that. So it's going to say, okay, it goes through, it finds our hour for us. We've got that here now. So now it's going to say if we're a unique device on a Wednesday between certain time. Ooh, actually, we might need date too, do we? Gotta think about this. Unique device. Unique devices on a Monday. No, I think that's okay. It's out of browse. It's out of browse here, and then we can actually summarize this information as well. We're gonna want to group by. I think we want to group by. Actually, let's run this first. See what we get. You guys are kind of learning with me here. Okay, so here's the same user twice, which is okay because he was here on Wednesday, but in two different time slots. So that we want that. So that's okay. How many records is this? 64,000. Let's save these out real quick. Let's go ahead and open those up. Oh, I put them in my other version in here. Results. Okay, let's take a look at this. All right, so here's the same guy, different days, but he only came on Saturdays at different hour times. So I think that's okay. And then we just need to group these then. So I think we need to make a day of week and hour combination. And then bucket those. So how would we do that in Ultrix? So let's do. I think we can do it with this. Oh, maybe it's that filter. No, it's not what we want. I think we're almost there. I just need to add one more field. And then we think we'll be good. I thought I could add fields in here, but I guess I can't. Not spatial. not select. So hash ID, day of week, hour. I just want to summarize these. Maybe I can just do it in that summarize tool. I don't know if I can group by two things though. Hey, Krunik. Man, I could have sworn it was in here. It's not though. Krunik. Krunik. Hey, do you know where the add field is in Alteryx? The add column? Like, I want to add a column and do a formula to it. Do you know what that thing looks like? I don't think it's that.
Input data?
Well, no, I inputted it here. I just need to add another column, and I need to do the math to it. I mean, I guess I could go look in. I guess I could go look in here real quick. 'Cause he's done this like a million times in here. Let's go take a look. By the time I'm done, it may have been faster to run these. No, it's still not going to be faster to run these through. Okay, I thought it was this tool. Nope. Snowflake select. Yeah. Oh, maybe it's this thing. Formula. I know. That's what I need to do. Create a new one. So, where does he create it though?
Right click
In here? No.
add. Go to options.
Might be this formula tool. Where's that formula tool at? Because I do want to do a formula. Select add a column. That's where it is. So how do I add it? Oh, it's add a column like to here. Because I want to do day of week. He calls that index. Yeah, that's good. But then what column is that going to put that in? The field is not contained in the. All right, let's go back to this. So he's adding this to diff. So where does he add diff at? What, those just came out? That's funny. Yeah, I know. Yeah, it is kind of weird. I agree. Dude, I don't know how to make a new column here. It's frustrating. I don't want to select a column. I just want to make a new column. And then I'm done. All right, let me go back to here and see what he does. Formula, time of sight. No, not summarize. Alright, so I'm gonna go see if I can find this real quick online. Figure out what I need to add. Simply create a column with the formula tool. That's what I got. Formula tool. Though really, you have to click the plus. Hello. Okay, there we go. Jeez Louise, no big deal though. Moving on, got our thing here. So now we just want to count these up. So we're gonna group by that, and then we're just gonna get a count of those. We should be good to roll. Okay, so let's take a look at this. This should be all we need now, even though that just took 20 minutes, but okay. So yeah, there we go. So we just basically created that exact same chart that is right here. So we got that exact same chart right there, but now we can just pop our other ones in, save these out, and then this is the only numbers that we're really concerned about here. So I'm gonna save this out, and we're just gonna put these all in one area, and then that way we can do all of our math next to it. So this is day by hour results, and then we'll just start popping all these in here. So that was got like 9 spellings for the Ellen, so hopefully whatever one we deliver is the right one. Okay, so now we can just pop these other ones in here. So we got that one. Let's go back up to the top now. Bellevue. Pin. So it took a little work up front, but we didn't have to wait for the whole model to run, and this should get through this pretty quickly now for each of these and just get the data that we need for this one pager. So I'll get those. actually not going to do the current Italies only because those aren't the whole entire sites, and these are. And so this comparison for the times will just be on the ones that they're looking at in Seattle. We're not going to include the actual Italy locations for comparison. We're just going to include the 5 potential sites that they'd be looking at in Seattle for the time of day and how busy it will be. Surprised we still have 25 people here. Is if you're still paying attention, maybe throw an emote in the chat so I can see how many people are still paying attention. All right, we got a couple in here. All right, almost got all these here. Got maybe one more, maybe. I think I already did that one. So University Village. Okay, so that should be good there. Okay, so those are our 5 sites. All right, so we got the data now, so we should be good to go here. Let's see, let's jump back out and get our results by hour. Okay, so we've got our spreadsheets now. So what we're gonna make, I don't know if we're gonna make the chart look the same. Let me show you what the old chart looked like. But maybe make it both ways, and we can kind of decide on what we want to do here. But let me show you what that comparison chart does look like from the old one. I think I do have it right over here somewhere. Maybe not. Italy. So here's what the last one looked like, which was this chart here. I'm gonna maybe recreate this chart, but maybe also do one that looks like our normal charts that we do, those day by hour graphs. I don't know if that maybe will show this a little bit better. So, but that's kind of what we're trying to recreate. So let's take a look here. So we gotta open up all of our files here. So for anybody that's done any of these comparison ones, you can already see how much how time consuming they can be, just because the model will get you a lot of the way there, but I mean there's still just a lot of stuff that you've got to do manually, and that's just the nature of the comparisons. I'm not even. I mean the model maybe could handle this at some point, but um, I'm not really sure. It would be a pretty big task to help it or to create it so it would actually do these comparisons for you. So I'm just getting all these in one spreadsheet because we're going to need all these numbers side by side. So what we have here now is unique individuals by day during their correct time, like whatever time slot they were there at. So we can now we can start to do some comparisons of how much like how much more busy. That's not even a sentence. How much more busier? Maybe it is. I don't know. How much more busier one side is than the other at the different times of day, but all on the same scale. So we got kind of a lot going on here. So the first thing we want to do though is we do want to make sure. I don't know the best way to do that. Working with all this data at once here, I definitely want these to be good all the way across, like all the same time things. They look to be. Let's do a spot check here just so make sure these are all lined up before I delete out all these other date columns. They look like they're okay. All 21s. All the Sundays are there, so that's good. Yeah, Jen, yeah, you wouldn't want to be the one explaining it, that's for sure. Okay, so I think we're good there. So I'm gonna get rid of all these other day by hours. I think we need these. They're all lined up now. University Village. Okay, so there's kind of there's all of our numbers. Okay, so what we want to do now is we want to create an index for all these, but instead of doing it based off the individual site, we're going to do it based off this whole data set. And that'll allow us to do those comparisons. This one is 2 times as busy as this one on an average hour. So what we're going to do is we're going to take the average of all these here. So every time slot by every day, what is the average number of devices that we see? So on any given day in 1 hour's time, we see on average 1,409 devices. So that's going to be our baseline for all these sites here. So now we're going to compare what we saw at each of those times to our baseline. So we're going to just copy this. We're actually going to paste it right back over here. We're going to get rid of all this data because those were the counts. Now these are going to actually now be our index values. And we're going to go to each one of these. So we want this one. We want to divide it by the average. We want that to stay there. And we're going to multiply this by 100. So it has an index of 2, which makes sense. There's only 31 devices there seen on Friday between midnight and 1 a.m. So we can call that bad data. I'm not quite sure what that is. It'll kind of weed itself out though as we go. And I don't know. Can I drag that across? It's D3. Yeah, so we're okay there. Should be able to double click this down. And as you can see, we have everything highlighted, and we can see that the average for those is 100, which is what we want. Now, when we graph this, let's see here. This might be all we needed to do. Let's see what they recommend. Yeah, so that was what I probably expected. I'll have to see the best way to visualize this because we're not going to see much unless that just shows us that Bellevue is pretty much always busier. I'm just thinking in my head right now about so this graph here. This might be one of those scenarios where we need to another part of the comparison that you need to think of quite a bit is what we already did on that second chart, which is how do we normalize for the different sizes in the um, in the properties. And so the reason that's the reason that's maybe significant is because Bellevue Square, it has a lot more people automatically, and so it's already inflated on this chart. But we did see that when we did the analysis for square footage, that the Bellevue Center wasn't the top center. So, like right here, and the reason that is, or the reason it could be, is because if we go back and look at our geofenced areas, so we're only pulling pins for this small area when we're looking at Pacific Place. University Village, I mean, maybe twice the size. Bellevue Square is huge, so there's a lot more opportunity for pins here. Um, so just inherently, it's going to be a lot more busy. It's going to be a lot busier. But we could go back and divide our numbers by square footage again to kind of account for that density. So I'm going to go ahead and do that just because I'm curious to see what it looks like. Um, and it's just like I said, this is like one of those things where it gets difficult, and it's really depending on what you're trying to show um, to the client. But on a comparison metric, we have different sized geographies here, which accounts probably for some of that variability in total number of people. Um, and so the times themselves, we have obviously more opportunity at Bellevue than we do at some of these other sites due to the size. So we're gonna use some of those square footages that we grabbed earlier. So I'm actually gonna leave this page as is. Let me start a new page here. And I'll ask Patrick actually. He made this last one. Let's see what he did. If he used density on those. Hey Donahoe, did you use density when you do these? Oh yeah. Oh yeah, yeah. What was your little method? Okay. Okay. So the average. Okay. So the methodology that was used on this one here is it was actually run both ways. So this is we'll call this our raw count. This is our raw count index. So this is not accounting for the size of the space at all. This is just saying number of pins, and we could see here easily that we have different sized locations, and so different opportunities for areas to capture. So he did the raw count, which is this one here, and then we're going to do the exact same thing, but we're going to call this our density index. And then he actually took the average of both of those to come up with that final index. So you could choose one or the other. Um, I think on the comparison one, if you were going to choose, most likely we're probably going to use this density. But we can look at them a couple ways. So here's our raw index. We'll look at our density now. So we're going to use our values that we got from here. This one, this comes back to this whole total square footage versus square footage of the polygon. I'm assuming we probably just use the square footage of the polygon on this version, just because the number of floors really only happened for the first time on that last one. So let's grab these numbers real quick. Let's pop these over here. So we didn't. Let's see. Okay, so we don't need this one, and we don't need this one. So let's just pop these up here. So these are our square footages. So we're going to do really the same thing we did when we had the total counts. We're going to take this, get rid of all these counts, and this is going to be our density count here in a second. So on a Friday at between midnight and 1, if we looked across the whole center per square foot, let's see, that's University Village, which is right there. Let there's going to be like nobody. Yeah, it's going to be a really small decimal, which is fine. So we're going to get these really small decimals for how many people per square foot, but it's okay because we're going to convert this into an index. So they would, I mean, they're never going to have to like try to decipher what that even means, which, I mean, it'd be pretty hard to wrap your head around that because that's such a small number. Yo, yeah, it counts. Yeah, I don't want to do that though. I mean, yeah, I see what you're saying. I mean, yeah, we could do that at the end. Yeah, multiply it by 40, was it 45 something? Macy's. And then we've got our last one is Bellevue. So we got this count divided by our square footage. And that needs to be that. Let's see, 5. That's Macy's. I just want to make sure these are right because this will mess up the whole thing. Okay. You can use a sweet little paintbrush. I don't know if you guys have used that. I think it's pretty awesome. And that one's going to mess it up. It's fine. Okay, so here's our people per density. And we'll see probably a significant change here in this chart. So we're actually going to take the average of this now, our average of these, and we're going to do the exact same thing again. Except this time, we're going to divide this by this. Okay, so then we can see what our chart looks like now. And then we can try it too with putting everything together. I really want this to be at the top, but see if it lets me. Okay, so we got a little bit more going on here. Um, this chart may not be the right chart just because it's actually hard to see now on before, after, like the actual times. We can see like these peaks and valleys, but that other box maybe makes it a little bit easier to read. Um, but what this is really showing us here is just relative to the size of the place. So in our chart here, we got to remember we do have a couple metrics going here. So we do have the total. So they know Bellevue Square is way busier than the rest of them. I mean, it's 2 times as busy as Pacific Place. Um, so they're going to know that. They're going to have a comparison here, which is going to kind of show them, okay, that's the density mark. So Bellevue Squares, I don't think was #1 on this chart. I think this is Chicago, and then it kind of went down from there. So they'll be able to kind of see, based off the size of the project, though, and just the area that people are going to travel, they'll be able to see kind of what that comparison is. Then when they get to this chart, um, and this is maybe we do, since we already have, maybe that's what we do, since we already have 2 here. We have kind of our total, we have our density comparison. We could almost do that same thing here, where over the whole space, like Pacific Place has more people per square foot in the actual area than say Bellevue Square, but Bellevue Square still has a lot more people, and so we can see what the average looks like too. Let's do that now. And sorry if this is getting like a little crazy here. We got a lot going on here. So if you guys do have questions, let's see. He gets much less volume. Let's see. Yeah, so most of the projects that we're working on are pretty much like this. Um, I just see in the chat there like less volume, more extra time. Um, a A lot of it, that's usually is the case, just because I mean you literally sit here and then your brain just fries on in Excel. But there's just a lot to think about, and then a lot of vetting out, and then just different ways to approach each project. Like we might have another comparison project that it might not require us to go maybe into this depth, or maybe we'd have to go even a whole different route. So I'm going to copy these. I'm going to call this this is like the blended. So we've got, let's get our raw counts first. See what this looks like. All right, so this is raw. Oops, we'll get our diversity, or density, I mean, here. Now, I don't know if you can add, let's see what happens here. So this should be 100. Yep, that's 100, so that's good. That's 100, okay. Let's take a look at this and see what we get here. I don't know if we need to average these or sum these. Nope, we're okay averaging them. Okay, perfect. So our average is still 100, which is what we want. So this one, I'm assuming Bellevue is going to have kind of a comeback here. So let's take a look. Which I think in theory it should, because we do want to show that it, out of all of them, this is probably the chart that makes most sense. Because we know Bellevue already has a way larger population. So if we put both of those together and kind of take into that account, we still see Bellevue, but now we have some more separation here between our charts, which is nice. Um, so what you can really get from this, though, is, and I think if we break it down in that other chart, I'll go ahead and make that other chart to see what it looks like, is we'll be able to say, okay, at the dinner time, you've got this amount of X people versus, this amount of X people at these other sites. So it's starting to seem like this Bellevue Plaza or place is at least a runaway when we're looking at just the amount of people. Now, there's always that whole other side to the real estate equation, which is, cost and different things. Where it's, can you maybe go to Pacific Place for much less, even though you see half the amount of people, but it's still enough to support in Italy. So those will be all the fun stuff that the brokers get to work through. So I think this next chart, probably just going to stretch this one across, I think, this whole area here. And we'll just do a pretty good size chart in here, grouping these together. That's what I think we'll do. The whole goal of this second step to this project was, at least for Italy, was those other packets were, I guess, a little bit too cumbersome. There was a lot of data there, and they were really only interested in a couple points. So we're trying to come up with a version that we can maybe model out when we're done. So I'll save some of these Ultrix models that we just did, and so we can create these really quickly, well, as quick as possible, with this methodology going forward. So this is going to be our, let's see, day by hour comparison. And we'll get that chart in there. And then I'm not sure what we're going to do down here. There's some other stuff in the packet that they kind of wanted to see. It might just be some of this demographic data here. So like kind of our total visitors, retail spend, some kind of chart that kind of identifies these. Um, we did some frequency stuff here, so how often we saw the same unique ID come back. I think that may be it. I think on these ones here, they weren't so. I mean, they like the heat map and where people are, but they'd like to just know right here in this area, like what is the estimated count of people passing through there, like right where their storefronts are going to be. So we may have to do some math on that to calculate those. And then this chart here, we might want to go through just like he did, and that might clean up our data a little bit too. He's got like buckets here, so 4 a.m. to 10 a.m., 10 a.m. to 4 p.m., 4 p.m. to 10 p.m. I think these were specified by Italy of the time frames that they wanted to see, and so that'll actually probably clean our chart up quite a bit instead of all these different data points that we have right now. Our graph will be much cleaner, much less points to plot. Which though requires a lot more work on our side because we're gonna have to go through and put these into the appropriated buckets, which is really, let's see. So this is gonna be morning. Let's see, that goes to 10. I think that's 9 to 10. Let's see, this is gonna go to 4 p.m. This is 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. So I guess these ones will be left off. Let's call these null, I guess. So we should be able to just copy paste this down. What? What does? You have morning starting at 4. Oh, yeah, why did I do that? Yeah, null. Yeah, you're right. So that's midnight to 1, 1 to 2, 2 to 3, 3 to 4 is right there. Yeah, that's a good call on that one. Morning would have got I guess it would have been a small boost, but okay, so got that. Put these down here. This is going to be like some wicked pivot table or something we're going to have to do here. So I don't need any of the nulls. I don't even know if I can make a pivot table out of this. Let's take a look. Okay, so I think our buckets are our rows, and then there's already. Oh, I see. All right, hold on. Bucket. I think we want. Oh man, dude. Oh no, dude. University, Ellen, Pacific, Macy's, Bellevue. Dude, this is such a cluster. Donahoe, would you find the easiest way to sum these? Just literally put a break in here. Just put a break in here and sum them. Oh, over here. Okay. Yeah, I need that. So that's what I need to add. I need to add the day. Oh yeah, I got it. Okay. Yeah, I'm thinking about it. Yeah. So I need this. I need data text to columns underscore equals this and equals this and this. There we go. So we got that. This and pivot. Okay. So I think that's what we need there. Okay. So this just got. Okay. So we ran that pivot table there. Oh man. Okay. So this gets a little crazy. So we're trying to link these and count these by groupings, and so the easiest way to do that is probably with this pivot table. So we know that these fall within our morning hours, and then we just need to know the day. So we just attach the day to morning. So the way the pivot table works is we're going to find all the unique values. So it's going to group all these together because they all say Fry morning. Um, and it's going to go, and then we said sum all the Fry mornings of Bellevue. So if we go to Fry afternoon over here, which is right here, and we sum all the Bellevue ones, which are these, our sum is 46,661, and it's 46,661 in this table. And so instead of, you could make a bunch of gaps in here and add them up and do all that kind of work, but it's going to be a lot of work, so you're not going to want to do that. So if you can, these pivot tables are pretty awesome. And so we'll take this and let's put it back in our raw data area here. And now we're just gonna do the same process real quick. So these need to be in order. Not really gonna worry about that right now. So like any of these nulls we don't need actually. Let's get rid of these. So we don't want any of these nulls in our final calculations here to mess that up. Let's resort these by row labels. We'll still have to kind of move these around, but let's just go with this for right now. So now we're going to create that index again. So this is really going to look the same, but it's just going to be less categories, a little bit easier to digest when they're looking at the content instead of every hour. So this should average out to 100 again as well. So there we go. So now we have those buckets. Just like I said, it'll be a little bit easier to see, a little bit easier to digest when they're looking at it. And then again, we'll have to go put these in order. Morning, afternoon, evening, morning, afternoon, evening. Actually, probably won't be that bad. Might even be, yeah, figure that out. Okay, so that's good. And then we have to do that again, though, for our density as well. So when we do those buckets, the good thing is we can probably use that same exact, probably use this exact same column here, this bucket column. Actually, we might, I think we actually just would want to copy this whole thing over because these were in the same order. Let's do a quick check here. Friday, null. Mondays, good. Mornings, Thursday, nulls. Tuesday, yep. So that's good all the way down. Link those. I'm going to delete this pivot table out. Get one on this. So for all you GIS fans out there, we haven't done much GIS today. It's been a lot of pivot tables. I mean, we've done a couple spatial joins to get to some of this data, but a lot of the massive mobile data is going to be, I mean, it's just going to be really working with the amount of number of records and kind of sifting through the data, especially when you get to kind of doing some of these comparisons. And then we will at some point get back into the actual kind of math of it, but right now we're not going to be able to. So actually, now that I think about this, this chart should be the same, and it is the same. So we didn't even need to recreate this. We just need to take these values and divide them by the square footages here. So I'm going to get rid of this, get rid of this. So we just created that chart twice, really, for no reason. But sometimes you'll have that. This. Recreate this chart, but with the density numbers, which are going to come from over here. Okay, so let's go ahead and do these. So we got our Bellevue divided by our Bellevue square footage. Macy's, divide that by our Macy's square footage. Pacific Place, divided by our Pacific Place square footage. Oops. Ellen divided by our Ellen square footage. And our last one, and then we'll get that final chart going. University Village divided by our University Village. Okay, so we got those. We'll get our average. These ones we should just be able to drag over. And then we'll have our final chart. We'll get our averages, and then we will kind of be on our way here. This should equal 1. Oh, we got to multiply these by 100 just to get us our index that we're used to. And then we should have our average of 100, which we do. And we're going to just come all the way back over to here. We'll get our raw count. chart, our new raw count chart, which is here. Raw. We'll get our density one, which we have here. Pop that here. Hold on. That doesn't look right. Unless I missed some of them on the last one. I mean, I guess this is the same chart, but why? Did I just not copy all of them? It's not copied all of them. Well, let's redo this real quick. It's kind of weird. This. It's kind of weird. Oh, that's why. Nope, hold on. That's what that was. That was the reason. Yeah, I did on the last one, but I didn't do it on this one. Thank you. Yeah, so what I didn't do, the reason those didn't line up is because I left these nulls in here. We actually don't want these nulls in here. That's why. Thank you, Donahoe. I would have got there at some point. Okay, so our average is going to change, which is fine. And then we gotta, let's just recopy this over and get rid of these and get rid of those. So we had those null values in there. We definitely don't want those. Because that'll mess everything up. Okay, so now we should be good. There we go. And then we'll just make sure that these are the right columns. They should be, but those are good. And then we'll make our final chart over here. We'll see what that looks like. Oops. All right, now we just got to get these in order here. So let's see. Whoops. I don't need to use the header there. Okay. So I don't know. Probably start with what did you start with? Let's see what Dono started with. So he started with Monday. Okay. So 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so we should just be able to do this final sort and be good. Okay, so here's going to be our final, I think our final table here. So this is the table essentially that is already created. It's in a little bit different format. He's got the days of the week on top. I mean, we could just transpose these. Um, but this is essentially what's already been created. So if you followed this down, you'd be able to look across. Tuesday evenings. Um, Bellevue's got quite a few. Macy's has above average. Pacific Place does. But when you look at University Village and the Ellen, I mean, they're well below average. And actually, these two sites compared to the other don't ever stand a chance. But these three sites, I mean, you can see kind of some variations. So Sundays afternoons, this Macy's location is actually below average compared to these other two. They're actually pretty busy on Sunday afternoons. Um, Sunday evening, Bellevue stays busy, but Pacific Place kind of drops off significantly. So these are good things they want to know. And in the weekend, maybe I don't know how much of the weekend traffic that they're interested in, but when you're looking through weekday and you're looking at evening, you can kind of see Pacific Place. Even this Macy's location is still above average. So these are kind of holding their own. And then you can kind of say, okay, but you know, this Bellevue's three times as busy. So there is some big discrepancies there. I mean, here's an evening. So Friday, the Macy's actually sees a bump, but during the week, the other weekdays, I mean, Friday's almost kind of like a weekend, Friday evenings, but like Thursday evening, Wednesday evening, Tuesday evening, that's kind of interesting. They actually are kind of above average again. And then Monday evening, right on it. So midweek, though, take a big hit. If they're looking for consistent busyness throughout the week during those evening hours, they'll be able to see that from this chart. Um, so to get this chart over here, what Patrick probably did, you can use these conditional formatting, which is kind of cool. You can set these color ranges and choose your colors um, to kind of whatever scale. I think that may have been what he did here. You can actually really create this chart right inside here just by messing with all the stuff. And then to get it over into AI, you're just going to copy paste it. You can do some minor adjustments to the fonts and stuff, but really that's your chart. So there is some pretty easy ways once you stylize it in Excel just to copy paste your data right over, and then we'll kind of format this and we'll put that chart right inside there. I probably will do the chart the other way though, um, which is kind of transposing this. I don't know if I can do a straight transpose. Yeah, we can. So be something like that. So now we can see Bellevue, the different times it's busy versus um, and we got to do our color formatting different here, just so it matches up to the other one. So let's see, conditional formatting, color scales. We want the higher numbers to be red, so something like that. Um, but I'll go through and change the colors, but that'll be kind of that chart though, created, and we can clean this up, make it however we want. I'll probably just get the AI file that Donahoe already created and just put my chart in there. That's what we'll end up doing. So let's see. Let's go through these. I think we'll probably be wrapping up here. Just gonna read through these comments real quick just to see if I miss anything. Let's see. I think Lisa's Tim saying The Pom Pom. I mean, if I had the song, I can maybe do a little bit of it. End of the day, not. Let's see. No, I think we, so. Yeah, I think we answered everything in here, at least as of now. If you guys have any questions, um, I mean, some of this may have been boring, some of it may have been interesting, but if you guys have any questions about the methodologies or any of the stuff that we've done in more detail, um, definitely happy to shoot me an email, or definitely happy to chat about some of the products. Or again, if you have a heat map, or a client that's constantly requesting the exact same heat map, I can work with you to help get some of those into a model, so you're not wasting your time doing the same heat maps over and over and over again. You can just make the model. I mean, we saw that one run on here today in 5 minutes, and you're good to go. You make your thematic, you create your map, and you send it off. So yeah, I think that's it, man. Smash that subscriber button right down here. Um, I don't know when the next one will be. Pretty much just be waiting until Marco says, "Hey, do another one." Or I think there may be other people maybe going to do some of these. So and also let us know if it was helpful or not. I mean, this is the first time we're doing it. I think Niegosh he might be sending something out, but maybe shoot him an email like, "Hey, that was lame," or I got a couple good things out of it. I'll be posting my streaming schedule. I'll send that out, you guys, and so you can just kind of hop in, maybe get some notifications when I come back on. But other than that, have a good weekend. I don't know what my outro is. I haven't really thought about it. Um, so next time I'll come up with something. Talk to you guys later. Peace.